Let's discuss rational numbers here. The simple way to think about it, it is any number that can be expressed as the ratio of two integers. While its definition states that any number that can be expressed as the fraction p over q, where p and q are two integers and q is not equals to 0, is a rational number. Keep this understanding up here and try to express the following number in form of fraction. One can be represented as 1 over 1, or as negative 2 over negative 2, or as 10,000 over 10,000, or as any number over any number. In all of these cases, 1 is represented in form of fractions. That means 1 is a rational number. Next, try to express negative 7 in form of fraction. Negative 7 can be expressed as negative 7 over 1 or as 14 over negative 2. Since negative 7 can be expressed in form of fraction, that means negative 7 is also a rational number. So far we have checked one positive and one negative integer, that shows all integers are rational numbers. Next, express the following decimal in form of fraction. .75 can be represented as 375 over 100, or this could also be reduced to have 15 over 4, which is another possible representation of 3.75 in form of fraction. Well, what does it mean? It means 3.75 is also a rational number. In general, any integer or decimal that can be expressed in form of two integers that are p and q, where q is not equals to 0, is a rational number. Next, let's look at non-terminating decimals. Non-terminating decimals are decimals in which decimal places do not terminate or end. They keep on going forever. Here are some examples of non-terminating decimals. 0.333. This 3 is going forever. This is also represented as 0.3 bar. This bar shows that the number under the bar is repeating forever. While 0.3 bar is also a fraction, that is 1/3. You can check it out. If you divide 1 by 3, your calculation will never end. Similarly, we have 0.666 or 0.6 bar, which is also a fraction, that is 2/3. And 0.222, which is 0.2 bar, it is also a fraction, that is 2/9. There are a lot more such sort of decimals. Those do not end and the same number is repeated forever. These decimals are known as repeating decimals. Since repeating decimals can be expressed in form of fraction of two integers, so all non-terminating repeating decimals are rational numbers. Lastly, there is another kind of non-terminating decimals, where instead of a single number, a specific pattern occurs again and again forever. Like we have 0.1818. This 18 is repeating forever, which is represented as 0.18 bar, and which is equals to 2/11 or 2 over 11. Here we have two more examples of such decimals, like 0.125125 going forever, which is written as 0.125 bar. Next, 0.8333 going forever, which is written as 0.83 bar. These sort of decimals are known as recurring decimals. In my next video, I will discuss how non-terminating recurring decimals are converted to fractions. But for now, you should know all non-terminating recurring decimals can be converted in form of fraction of two integers. So, all non-terminating recurring decimals are also rational numbers. Before we end this video, let's have a preview of rational numbers. Every number that can be expressed as the ratio of two integers p over q, where q is not equals to 0, is a rational number. As we have discussed, all non-terminating, repeating and recurring decimals are also rational numbers. We have only one case left behind, that is, only non-terminating and non-recurring decimals are irrational numbers. In the last of this video, I will share few examples of irrational numbers with you. Starting with square root of 2. If you find the value of square root of 2, your calculation will never end, and it will keep on going like 1.41, 42, 13, 56 and so on. You can see this decimal is not terminating, and even there is no pattern of occurrence. So this is an irrational number. Next, we have square root of 3. We also here have non-terminating and non-recurring decimals, so this is also an irrational number. In the last, I would share a number that we most often use in our calculation, and that is a pi, which is the ratio of circle circumference with its diameter. You will assume that the value of pi is not specified, and it is also an irrational number. If you find the value of pi, it will keep on going like 3.14159265 and 3 and going on. So this is also an irrational numbers. So here you have some examples of irrational numbers. So you should know remaining all numbers are rational numbers. Hope you have understood this, and you can now easily classify rational numbers and irrational numbers. Best of luck.